Hello. Hello, am I audible?
Good evening, ma'am.
Yeah, good afternoon, good evening, everyone. So let's wait for a couple of minutes since there are only 13 people. So you guys got the notification about the revision session, right?
Yes, ma'am.
Okay. So let's wait for 5 more minutes and then we'll start. Hello. Okay. So we'll start with this session with the introduction of functions. So we'll understand what is a function and then we will cover some of the basic functions, that is straight lines and quadratic functions. So for these functions, actually we have a general form. So using the general form, we can answer a set of questions. So those questions we will include. The second topic is the system of linear equation. So there will obviously one question from system of linear equation worth of 4 to 5 marks. And what you need to do is just to convert the system of linear equation into matrix representation and then reduce that matrix representation into required form. So that much process we need to learn. And the third topic will be sequences and their limit. So what we understand by limit of a sequence. So I'll take a couple of examples of limit of a sequence, and then we try to figure out how to compute the limit of those sequences. But with sequence, we have a very nice theorem which is known to be monotone convergence theorem. Monotone convergence theorem says that if we have a sequence with two properties, that means monotonic. Monotonic means either increasing or decreasing. So these type of behavior are known to be monotonic behavior of a sequence. So if we have a monotonic sequence that is either increasing or decreasing, plus with that property, if we have boundedness 2, then we can talk about the limit of sequence. So is my voice is clear? Is there any lag or double voice? Now it is clear, I hope. Okay. So, and the last topic is continuity of a function. Continuity means limit plus continuity. So first we'll understand what is the limit of a function. And we know that if we know the limit, then continuity is nothing but that the limit should exist and its value should equal to the value of function. So this is an overview of today's lecture. Now, first let's talk about the pattern of, or you can say the distribution of quiz reattempt qualifier. Okay. So the distribution goes like, so there will be again 15 to 20% of questions from week 1, right? So there will be 20 to 25% of questions. So I can say that definitely there will be 2 questions from system of linear equations, that is from week 2, and there will be again whatever we have. So again 20 to 25%, or you can take a little bit more here. So that is 25 to 30% of questions from week 3, and the remaining part from week 4. Okay, so merely if you want to I mean, since there are only 4 weeks and we just have very few topics, so it's better to go with the important topics. So important topics means these are the 5 important topics if you want to cover. Basic functions, so let's go with straight lines and quadratics. The system of linear equations, sequences, their limit, monotone convergence, bounded sequences, continuity of function. Okay, so let's start with straight lines. So I hope you guys know I hope you guys are familiar with mathematical uh, wording problems, right? So there are some questions, there is a question given to you in form of words. So for example, if suppose ram is the age of ram is twice the age of sham, and if there is a relation between those quantities, you can form an equation, right? So you have to form an equation and then solve it. Equation with the help of given condition, and then you can solve that. So those wording problems, I leave it to you guys because there are plenty of problems in activity and practice assignment. You can just go with those problems, try to solve them. You'll get a very good practice. So you can tackle those problems if such type of problems are in your exams. Okay, so I'll start with straight lines. So what is a straight line? Straight lines functions, right? So we know that what is a function. So function is nothing but a, so what is a function? So function is nothing but a rule or a correspondence for which that if f is a function from a to b, then for every element of a, there should exist a unique output. So that means, so a rule f from a set a to a set b is known to be a function if, so is a function if for all a belongs to a, that means for all element of a, for every element of a, there exists any unique b in B. So such a way that this function will take A as an input and give us B as an output. So such type of rules are known to be function. So a function is nothing but a rule or a map or a correspondence between two sets A and B. So it is a function from a set A to a set B if for all A belongs to A. So that means for all element of A, there should exist a unique element of B, right? So here we have uniqueness. So there should exist a unique element of B such a way that f will take a as an input and give us b as an output. So let's take some of the basic examples. I'll ask you. For example, if I have a map from a set A to a set B, and in my set A there are 4 elements 1, 2, 3, and 4, and in set B there are 3 elements A, B, C. So if I give you a map that this function f will take A, f will take 1 to A, f will take 2 to A, and f will take 3 to B, and f will take 4 to B2. So now, is this a function? So what will be your answer? Just write down yes or no in the chat box. So suppose a map is given to you like this, that 1 is going to A, 2 is going to A, 3 is going to B, 4 is going to B. So I have only 2 answers. So just write it down yes or no, whatever you feel. Yes, no, yes, no. Okay. So the answer is yes, this is a function. Why it is a function? So see, in function, we need to take care of 2 words. One is the every and another one is the unique. Right? Every means every element of A should get mapped to somewhere. Okay, so here in A there are 4 elements, and you can observe that for every element we have an output. That 1 is going to A, 2 is going to A, 3 is going to B, 4 is going to B. So that means this every word is satisfied here. That every element of A has some output, at least one output. Right? So here every element in A, which is 1, 2, 3, 4, has an output. So that means every element is there. Every word is satisfied in this particular map. Now, second thing is unique. So what is unique means that one element should go to one output. So for example, if I say that f of 1 is also A and f of 1 is also B. Now this is not a uniqueness. This is not unique. Uniqueness means uniqueness should present related to the output. So that means if you take one input, that one input related to one output, right? But it is possible that an output can relate to more than one input. So for example, here we are getting f of 1 is equals to A and f of 2 is equals to A. This is allowed in a function, because here what is happening, for a input you are getting an output, for a input you are getting an unique output, but it is possible that the output might be same for two inputs, right? So here unique word is there. Unique means for an input we should need a unique output. For an input we don't need more than one outputs. Okay, so that's why unique word is also here. So because of that I can say that this map is a function. So it is a function. Okay, so this is the basic definition of function. That it says that for all element of A, there should exist a unique element of B in B such a way that A map to B. But it is possible that an element can work as an output for more than one inputs. Yes, it is possible that for two different inputs, we have a same output. For example, you can take f of x is equals to x square. Right? We know that this is a function, and here f of 1 is same as f of minus 1, which is same as 1. Right? So it is possible that a element can work as output for more than one inputs. It won't harm the definition of function. Definition of functions means if you give that machine an input, it should give us an unique output. Okay, so that is the meaning. For a input, we need a unique output, but that output can be same for different inputs. So for you can consider this example, f of x is equals to x squared. And here, if we put 1 as an input, we'll get 1 as an output. And if we put minus 1 as an input, we'll again get 1 as an output. So this is not the meaning of uniqueness. Uniqueness means related to input. So that means if you put 1, you should get only one thing here, right? So if you give a star input, you should get a specific output. It should not happen that this star can also give this is our output and another one as an output too. So this thing is not a function. So what I mean, so if you have an input and this input is going to two different output, then this is not a function, right? But if you have an output which is get mapped to by two distinct input, then yes, this is a function. Okay, so this is important to understand. Yeah. So uniqueness related to input is important. So now we have some basic functions. One is the straight line. So what is a so we know that notation of function. So we can denote a function using several things. So we can draw the graph of function that will also tell us all about the function. We can have an expression for that particular function, right? So these are the two common ways, or we can give us a set of input and output, just like this matching kind of thing, right? As like this. So this is another way to denote a function. But in general, we use two ways. One is the graphical ways. So we can have a graph of function, or we have a equation for that function. Okay, so these are the two important things related to a function. That if we have a function, then what will be the graph of that function, and how can we find an equation for that function? So what is the equation means? We need to find a relation. So find a relation between x and y such that if you take the pair x comma y, then that pair satisfies the function. So I'll come back to this equation type once again. So let's see what is a straight line means to us. Okay, so straight line means straight line means just like a straight line. So here, if we have this particular straight line, and if we have 2 points on this straight line, x1 comma y1 and x2 comma y2, then how we can find out the equation of a straight line? Okay, so for equation of straight line, there are several representations. So we uses the slope intercept formula. So the equation of straight line is that y is equals to mx plus c. Okay, so what is m here? So m is nothing but the slope of a straight line. Slope, right? And what is a slope? Slope means the change in y related to change in x. So that means if 2 points we have over the straight line x1 y1 x2 y2, then change in y means y2 minus y1 related to change in x, that is upon x2 minus x1. So we can use this formula to find out the slope of a any straight line. And what is c here? So c is nothing but y-intercept. So y-intercept means the point where the line intersecting y-axis. Okay, so in this figure, this is your y-intercept 0 comma c. So here, whatever the value of c is there, that is known to be a y-intercept. So this is a one equation of one type of equation of a straight line. So the equation of straight line is y is equals to mx plus c, where m is nothing but the slope of a line, and c is nothing but the y-intercept of a line. Okay, so now we have one more representation of a straight line, which is known to be the two. If we have 2 points over the straight line, then using those 2 points, we can actually find the equation of line. Okay, this is known to be 2-point formula. So suppose, okay, so if x1 comma y1 and x2 comma y2 are 2 points on the line, then equation of line will be y minus y1, which is equal to y2 minus y1 upon x2 minus x1 into x minus x1. Okay, so this is another formula by which we can compute the equation of line. If we have 2 points x1 comma y1 and x2 comma y2, which are lying over our line x. Okay, so there are basically only two formulas for a straight line. One is the slope intercept formula, y is equals to mx plus c, and the second one is the 2-point formula. Okay, just give me a second, I'll be back. Hello. Yeah, sorry for that. So where were we? So we are talking about two equation of line. So one is slope intercept formula. So we can take y is equals to mx plus c. If we know the slope of a line and y intercept, or else we can have a 2-point formula. So if we know that these 2 points are lying over a line L, then we can use these point formula to find the equation of line. Okay, so that's all about a line. Now we can move toward the second kind of function, which is the quadratic function. So quadratic functions means what? So as the name suggests, the quadratic means the degree 2 functions. So if we have a function y is equals to ax square plus bx plus c, then such type of functions are known to be quadratic function. So the graph of a line is very simple. It's just a straight line, so we don't have to bother about that. But when it comes to quadratic function, the graph of quadratic functions will represent a parabola. Right. Now there are two type of parabola, upward parabola and downward parabola. And here we are not considering such type of parabolas which are not function. So if you consider these two kind of parabolas, so in your higher studies you have learned about 4 types of parabola, right? So we have these 4 types of parabola. So if you observe that these two figure actually does not qualify as a function, because here what is happening, it fails the vertical line test. Vertical line test. So if you guys remember, we have a vertical line test for judging that a particular graph represents a function or not. So vertical line test means you will draw several vertical lines. So here if I draw several vertical line, I'll get a vertical line which intersect the graph at more than 1 point. Right. So here this is a vertical line which is intersecting the graph at 2 points. So if such a type of scenario happens, then those graphs does not represent a function. Right. So what is a graph? Graph is just any figure over the plane. So this particular figure does not represent a function because of the vertical line test. Okay. So I hope you guys remember the vertical line test. Similarly, this graph is also not qualify as a function, because here if you draw this vertical line, it will intersect the graph at 2 points. Okay. And this is the reason that it is not a graph. It is not a graph of a function. So that's why we only consider these two types of parabola when we talk about quadratic functions. So any quadratic function will represent either an upward parabola or a downward parabola. So it depends on the sign of x square coefficient. So that means it depends on a. So if the value of a is strictly greater than 0, again we are talking about quadratic functions, we assume that a is not equals to 0. Because if a becomes 0, it's nothing but a straight line. So here we assume that a is not equals to 0. So there are two choices left. A can be strictly greater than 0 and a can be strictly less than 0. So if a is strictly greater than 0, this actually represents an upward parabola. And if the value of a is strictly less than 0, then it will represent a downward parabola. Okay, so we can figure it out which parabola we have just by looking at the sign of x square terms coefficient. Now there are other things about parabola is, which is vertex and axis of symmetry. So what is a vertex and axis of symmetry? Okay, so if we have a parabola, then we know that this parabola will be symmetric about a particular line. So for example, here it kind of y-axis only, but if I consider this parabola, now here you can assume that if you place a mirror over this dotted line, then you can find out that this wing and this wing is nothing but a mirror image of each other, right? So such a line is known to be axis of symmetry. And where this line intersect the parabola, that point is known to be the vertex of parabola. Now, if we have a equation of parabola with y is equals to ax square plus bx plus c, then the coordinate of vertex and the equation of axis of symmetry, again, what is axis of symmetry is just a straight line. So we have a particular form, as you guys know, minus b by 2. So coordinate of vertex, again, vertex is a point, so we have x coordinate and y coordinate. So vertex is x coordinate is nothing but minus b by 2a, and y coordinate, so if you consider this to be f of x, then y coordinate is nothing but f of minus b by 2a. Okay, and similarly the equation of axis of symmetry is nothing but x is equals to minus b by 2a. Why this is so? Because we know that it's a vertical line and it intersects the x-axis at minus b by 2a, so that's why the equation So the equation of axis of symmetry is nothing but x is equals to minus v by 2a. Okay, so if we summarize that, if we have a equation of parabola y is equals to ax square plus bx plus c, then the vertex coordinate look like minus b by 2a and f of minus b by 2a, where this is our f of x. And the equation of axis of symmetry, equation of axis of symmetry is nothing but x is equals to minus b by 2a. Okay. Now there are one more thing about parabolas is the nature of their roots. So if we have a equation y is equals to ax square plus bx plus c, now we have a precise formula to find out the roots of parabola, which is nothing but x is equals to minus b plus minus under the root of b square minus 4ac by 2. So we can use this formula to find out the roots of any parabola. Now here, by observing this quantity b square minus 4ac, we can judge that our parabola has a real roots or complex roots or the same roots, right? So we have three cases here. So the first case is if the value of b square minus 4ac is equals to 0. So if b square minus 4ac is equals to 0, you can observe by the formula that x is nothing but minus b by 2a. That means here we have real and same root. Now, what is roots? So roots means those points, those values of x where function's value becomes 0. So that means if you substitute now minus b by 2a in your parabola equation, you will get f of x is equals to 0. So we want to find all those x for which f of x is equals to 0, and those values of x are known to be the roots of any function, not just parabola, any function if you have. And for that function, those values of x where the function is vanishing, that is f of x becoming 0, are known to be roots or zeros of parabola. Now, if we have b square minus 4ac is equals to 0, the nature of root will be real plus same roots. And those roots are nothing but x is equals to minus b by 2a. Now, the second thing is if b square minus 4ac is strictly greater than 0. In that case, we know that the under the root of b square minus 4ac is nothing but a real number, right? So here we have two roots, right? So here we have two distinct real roots. So the one root is x is equals to minus b plus under the root of b square minus 4ac by 2a, and another one is x is equals to minus b minus under the root of b square minus 4ac by 2a. Okay, now the third case is if the value of b square minus 4ac is strictly less than 0. We know that if this is strictly less than 0, the under the root of this quantity is a complex number, right? So in this case, we have a complex roots. That means we don't have a real roots in this particular case. Okay, so these are just basic theory about quadratic functions. Imaginary roots also you can say. Okay, now let's move to system of linear equation. Okay, so here I'll talk about the general method for solving any system of linear equation, and then we can either solve a question or we can observe a question for which we can apply our method. Okay, so one thing is if we have a system of linear equation with m equation and n variables, so that means a11 of x1 plus a12 of x2 plus and so on plus a1n of xn is equals to b1. Now a21 of x1 plus a22 of x2 plus and so on plus a2n of xn is equals to b2 and so on. The mth equation that am1 f of x1 am2 of x2 plus and so on plus amn of xn is equals to bn. Okay, so suppose this is our system of linear equation where here what we have n variables, n x1, x2 up to xn. So we have n variables and we have m number of equations, right? So if we have such type of system of linear equation, yeah, we can show that too. So for example here, so since b square minus 4ac is equals to 0, so in this case what happened, your parabola will touch the x-axis at its vertex point. So that means in this case, either your parabola will be something like this, or if it's a downward parabola, it will be something like this. The coordinate differs, right? So it depends on the root. But the parabola will touch the x-axis at a point. And in this case, what is happening? You have two distinct roots. So that means either your parabola will something look like this or look like this. It will intersect the x-axis at 2 points, right? And the third one is strictly greater than 0. So that means here the the parabola is not even touching or intersecting the x-axis. So it will something like this or something like this. Okay, the coordinate depend on the parabola. Okay, here I'm generally talking about. So in the first case, when b square minus 4ac is equals to 0, the picture of parabola will something look like this. So it will touch the x-axis at 1 point. In the second case, since we have two distinct root, it will intersect the x-axis at more than at 2 points. Right? So it depends on which parabola we have, upward, downward. And the third case, when we have a complex root, this parabola not even touches the x-axis. It will either lie in the upper half of the x-axis or the lower half of the x-axis. Okay. Now, if we have a such type of system of equation with n variables and m equation, then what we can do, we can convert this system of equation into matrix representation. Okay, so matrix representation, in matrix representation, we have three matrices here. So 1, 2, and 3. So here, we have the form Ax is equals to B form. Okay, so what is A? A is your coefficient matrix. Coefficient matrix means here you will contain the coefficient of each variable. Okay, but you will contain the coefficient in a precise manner. So for example, if I am writing the first variable is x1, then the first column of this matrix will contain the all coefficient of variable x1. Okay, so what are the coefficient of variable x1? So the coefficient of variable x1 is a11, a21 up to am1. So that means in this matrix we have coefficient will be a11, a21 up to am1. Now the second column, so if I write x2 here, then the second column will contain the coefficient of variable x2. So that means we will take a12, a22 up to am2, right? So a12, a22 up to am2. And similarly, if the last variable is xn here, then the last column of this matrix will contain the coefficient of xn, which is a1n, a2n up to amn. Okay, and this is nothing but your constant matrix. So here also the order depends on the variable. So if the first variable is x1 here, the first constant will be b1 here. If the second variable is x2 here, the second constant will be b2 here, and so on. The last constant will be bm here, because the last variable is xm here. Okay, so here you have to maintain the order when you convert the system of equation into matrix form. So now when we have such type of form that Ax is equals to B, then what we will do, we'll consider the augmented matrix. The augmented matrix means A augmented B. Right? So this matrix will look like A11, A21 up to AM1 and so on, A1n, A2n to AMN. So that means the whole matrix A with the constants B1, B2 up to Bm. Now what we have to do, we have to apply the row operations here. Again, I am emphasizing on row operations, because when we apply row operations, the matrix and the system of equation won't affect. So that means if you apply the row operation, you will still in the same system of linear equation. But if you apply the column operation and if you forgot to change the variables, then it is possible that you may convert your the system of linear equation into some another system. Okay, so it's better to stick with only row operations. So I'll again repeat, just apply row operations to convert your matrix into reduced form. Now what are row operations we have? So we majorly have three row operations. One is the replacing of row. You can change any row with any another row. Another one is the changing of row with some multiple of any other row. Or else you can do that, you can say that the row Ri is nothing but row Ri minus some multiple time of row Rj. So these three operations you can apply. So that means you can apply any row operations. So we just have these three row operations. So you can apply any row operation to convert the system, this particular matrix into reduced form. What is the reduced form? So reduced forms is something like this. So here we have some set of 0 rows. So it is possible to get uh, that there is no 0 rows in your reduced form. So it is also possible. The second thing is we have some set of diagonal values here. Then we have some non-zero values here. And then we have all 0 values here. Okay, and here we have constant, whatever constant we get. So this is our reduced form. So here we have particular cases by which we can judge that our system has a unique solution, more than one solution, or no solution. So I'll repeat those cases. So for example, this is our reduced form of a matrix. Okay. So here I will recall what are the notations we have now. So n is the number of variables. Okay, n is number of variables, or if you look at the matrix A, the matrix A has size m by n. So you can also think that n is nothing but the number of columns too. Okay, so n is the number of variables or number of columns. Now what is m represents? So m represents either the number of equation, or if you notice the matrix A, the size of a matrix A, it's nothing but the number of rows. So that means here we have number of rows too. So m is either number of equation or number of rows. Both things will be same. Now here we are also taking one more notation, which is r. One more quantity, which is r. So what is r? So r is the number of non-zero rows. So here that is r. So r is number of non-zero rows. Number of non-zero rows. Okay, so n is the number of variables or number of columns, m is the number of equation, number of rows, and r is the number of non-zero rows. Now using these three values and the constant related to zero rows. So for example, this is our zero row. So whatever constants we have here, observing the values of those constants, we can actually say that our system of equation will have a unique solution, more than one solution, or infinitely many, or no solution case, right? So what we need to observe, we need to observe the value of n, we need to observe the value of m, the value of r, and those constants which are related to zero rows. Okay, so which are related to our zero rows. And this thing we have to do after reduction. So that means once we get our required form, after that we have to observe these quantities. So let's see how what will be the result related to these quantities. Okay, so the first case says, if the value of r is strictly less than the value of m, so that means the number of non-zero rows is strictly less than the number of rows. And with this condition, we have that whatever constants here we have, so those constant will look like br plus 1, right, br plus 2, up to whatever numbers we have. And all those constants, among all those constants, there is one constant which is not zero. And if either br plus 1 not equal to 0, or br plus 2 not equal to 0, or any of the constant related to 0 row is not equal to 0. Okay, so in this case we can say that the system has no solution, right? Because what is happening here, we are getting 0 is equals to non-zero thing, right? We are getting 0 is equals to non-zero thing, something which is not 0. So that's why in this case we have no solution. So it's the first thing. First thing is, if the value of r is strictly less than the value of m, and the constants related to the 0 rows, so among those constants at least one constant is not equal to 0, then in this case we can say that the system has no solution. Okay, now the second thing is, if the value of r is strictly less than the value of n, so that means the number of non-zero rows strictly less than the number of columns. Okay, and if the constants related to 0 row all are 0, so that means, and if br plus 1 is equals to 0, br plus 2 is equals to 0, and so on. So whatever constants we have related to 0 row, all those constants are equal to 0. In this case, we will say that the system has infinitely many solutions. Because what happened in this case, we have a independent variable. So if you remember, we have one case where we can get an independence over the one variable. That means we can substitute any real number as that variable and get different solution. So this can happen in this particular case when r is strictly less than n and all the constants related to 0 rows are equal to 0. So then we will have infinitely many solutions. The third case is, if the value of r is equals to n, so that means the number of non-zero rows is same as number of columns, and the variables and the constants related to 0 rows, that means br plus 1, br plus 2, and so on, all those constants are equal to 0. So then we have a unique solution. Okay, so then what we have a unique solution. because in this case we can use the backward method. So that means with the help of this constant we can find out the value of each and every variable. Okay, so here we will have a unique solution when r is equals to n, and the constants related to zero rows are equal to 0. Okay, so these are the three cases we have. I'll repeat: when r is strictly less than m and the value of non-zero constants among at least one non-zero constants are not equal to 0, then we have no solution. If r is strictly less than n and the values of constants related to zero rows are all zeros, then we have infinitely many solutions. And if r is equals to n and the constants related to zero rows are all equal to 0, then we have unique solution. Okay. Now here I'll write a reduced form of an equation. You guys have to judge that this will have a unique solution, no solution, or infinitely many solutions. Okay. Okay. So suppose this is a reduced form of a system of linear equation. Then in this case, you will have a unique solution, or no solution, or infinitely many solutions. So what will be your answer? So what do you guys think here? What will be the answer? This system will have a unique solution, no solution, or infinitely many solutions. Okay, I have one vote over infinitely many solutions. Anything else? Anyone? At least just vote for one option. At least one, any one option. Non-zero rows means only you have to consider these rows, not the constant one. These will be your zero rows, and these will be your non-zero rows. Okay, so don't confuse with non-zero rows. Means you have to, uh, you don't have to look the constants here. Only rows related to the matrix A. These will be your zero rows, and these will be non-zero. Okay. So any changes in the option? Okay, I have 3 responses yet. Okay, so let's figure it out now. So let's observe the quantities R, M, N, and the constants related to zero rows. Okay, so here what is the value of R? So R is number of non-zero rows. So here there are 3 non-zero rows. What is the value of M? M is the total number of rows, which is 6. And N is the number of columns in a matrix A. Okay, so whenever we are talking about R, M, N, we are relating to matrix A, not A augmented B. Okay, so here in a matrix A, the number of rows is 6, the number of columns is 5. So here which case suits? So here there are 3 cases, that R is strictly less than M and then R is strictly less than N. Okay, because 3 is strictly less than 6 and 3 is strictly less than 5. So we can take any of the cases. So let's go with the first case. So the first case says if R is strictly less than M and any one of the constants related to zero rows are not equal to 0. So here what are the constants related to 0 rows? So 4 is the constant related to 0 row, 5 is there and 0 is there. So there are 3 constants, and among these 3 constants there are 2 which are not equal to 0. That means we can apply the first result and say that since B4, right, so this is your B1, B2, B3, B4. So now here B4 is not equals to 0, we can say this system has no solution. Okay, so that means the answer is B, that we have no solution. You can also consider the second case, but the second case won't applicable here, because in the second case, when R is strictly less than N, we need all constants to be equal to 0. But here B4 not equal to 0, B5 is not equal to 0, and B6 is equals to 0, but these two not equals to 0, so we can't apply R is strictly less than N case. Okay, we have to go by R is strictly less than N case. Only one is 0, but in the second case we need all of them should be equal to 0, not only one, because see, in the first case only I have written OR, but here we need all of them to be equal to 0. In both cases we need all constants related to 0 rows to be equal to 0. Okay, but here there are two constants which are not equal to 0, so that means the system will have no solution. Okay, is that clear, this question? Any doubt? Okay. So now let's go to sequences. So what is a sequence? So sequence is nothing but a function from a set of natural number to any set. So sequence. So sequence is nothing but a function from set of natural number to any set. So here you can take real numbers, rational numbers, irrational numbers, complex numbers, whatever sequence you want to build, you can build. But the thing is, the domain should be set of natural numbers. So those type of functions are known to be sequences. Now there are several notations about the sequences. So that means we can represent sequence in different ways. So we can just write down the expression of nth term, that is f of n is equals to 1 by n. Then this is represents a sequence with values 1 comma 1 by 2 comma 1 by 3 comma 1 by 4 and so on. So we can write an expression for nth term, or we can explicitly mention the term of a sequences, or else in place of f of n we usually write an. So an is also the representation of nth term of a sequence. Okay, so these are the three common ways to represent a sequence. Now there is one more way to represent a sequence, which is the recursion form. So it says that if a1 is equals to 0, or we can take a1 is equals to 2, and an plus 1 is nothing but 2 multiple of an. Right, so here what I'm doing, I'm giving a relation between the next and the previous term of sequences. So such type of relation are known to be recursion relation. Is my voice is clear? Is there any disturbance in the background? Okay. So here this is another way to represent the sequence just by giving the relation between the next term and the previous term. So here we are saying that an plus 1 is nothing but twice the value of an. And a1 is equals to 2. So if a1 is equals to 2, what is the value of a2? a2 says a2 is nothing but 2 multiplied by a1, which is nothing but 2 square. What is a3? a3 says 2 multiplied of a2, which is nothing but 2 cube, and so on. So we can take the values of a2. We can compute the values of sequence just by looking at the relation between the next and the previous term. Okay, so these are the ways to represent the sequence, just by giving the representation for giving the equation of nth term, or listing out the elements of sequences, or giving the recursion relations. Okay, so now on the topic sequence, we have majorly three concepts. One is the limit of sequence. Another one is the nature of sequence, that is increasing or decreasing, bounded or unbounded. Okay, and the third is computing the limit part. How can we compute the limit? Okay, so limit means existence of limit. Is the limit exist or not? And computing the limit means how can we compute the limit of a sequence? Okay, so I'll take one by one. So in limit, we have a very abstract definition of limit in lectures. That is that epsilon delta definition. So for an epsilon, we need a natural number capital N such a way that after that after passing that particular stage, infinitely many term of sequence should lie over the epsilon bond. Okay, but we know that we can't use this definition to find out the limit every time, right? So what we do, we compute the limit of some basic sequences, and then we use some algebra or rules of algebra of sequence to find out the limit of other sequences. So using the definition, we only compute one limit, which is limit n tending to infinity 1 by n. This is nothing but equal to 0. Okay, so using that epsilon and L definition, we computed this limit, that limit n going to infinity 1 by n is equals to 0. Now what we will do, whatever sequence we have, we either try to convert that sequence into this particular form. Okay, and we can try to find out the limit of a sequence. Now here, what is the meaning of limit of sequence is? So limit of sequence means if you take n goes to infinity, where does these terms an goes? Okay, so this is the basic question we need to answer when we talk about limit of sequence. Means if n is moving to infinity, where does the term of sequence an is going? Okay, this is the thing we need to judge. Now I'll take one more example. So suppose I'll give an is nothing but equal to minus 1 to the power n upon n. Okay, so then what will be your answer? Limit n goes to infinity an. What do you guys think? Limit n goes to infinity an will be equal to? Anyone can answer this question? Yeah, the answer is 0. Because what is happening? If you compute the several term of the sequence, a1 is actually minus 1, like minus 1 by 1 is minus 1. a2 is actually 1 by 2. a3 is actually minus 1 by 3. a4 is actually 1 by 4. But what is happening? Using both both sides of terms, so we are getting oscillated terms. So one term is lying over the right hand side of 0, another one is left hand side. So we are doing this thing, but ultimately as n goes to infinity, we are approaching 0 from both sides. So though these odd terms are also going to 0 and these even terms are also going to 0. So that means ultimately if n goes to infinity, we can say that minus 1 to the power n by n, this goes to 0 only. Okay, so these are another type of sequences whose limits we want to understand. So what you will do, you'll just take two partition of those sequences, the positive values and the negative values, and observe that if both values are going to the same value or not. If yes, then that will be your limit. If no, that means the limit does not exist. Okay, so here the answer is 0. As n goes to infinity, minus 1 to the power n by n goes to 0. Let me take another example. So suppose I have an example of the sequence en is equals to some n to the power 5 plus 4n cube plus 3n square plus 1 upon 6n to the power 5 plus 4n square plus 5n plus 6. Okay. So in this case, what do you guys think limit n goes to infinity en will be? So what will be the limit of this sequence? What do you guys think? What will be the limit? What should be the limit? So yeah, here the answer will be 1 by 6. Why is this so? Because as I told you, we need to do, we need to change our sequence into known limits. So we know that 1 by n goes to 0 as n goes to infinity. So in such type of question where the sequence written in the fractional form, numerator and denominator, what you will do, you'll pull out the largest power of n. So here in the numerator, the largest power of n is n to the power 5. So we'll pull out n to the power 5. What we will get? Here we will get 1. Here we have 4n cube. So how we can pull out n to the power 5 from 4n cube? So what we'll do? We have 4n cube. This is same as 4n cube into n to the power 5 upon n to the power 5. Right? We can multiply and divide by n to the power 5. And now we can pull out n to the power 5 from this particular term. So n to the power 5 we can take common, and then we will have 4n cube by n to the power 5. But this is same as n to the power 5 and 4 upon n square. So that means if I want to pull out n to the power 5 from this particular term, 4 into n cube, I'll get 4n square back and n to the power 5 common. So here I have 4 upon n square. Similarly, here you can get 3 upon n cube. And here you will get 1 upon n to the power 5. Just multiply and divide by n to the power 5 over those terms. Okay. So now similarly, we will pull out the largest power of n from the denominator too. If we do so, then here we will get n to the power 5 upon 6 plus 4 upon n cube plus 5 upon n to the power 4 and plus 6 upon n to the power 5. Now here n to the power 5 and to the power 5 will cancel out, and we left with 1 plus 4 by n square plus 3 by n cube plus 1 by n to the power 5 upon 6 plus 4 by n cube plus 5 by n to the power 4 plus 6 by n to the power 5. Now here what we can do, we know that since 1 by n goes to 0, 1 by n square, 1 by n cube and any power of 1 by n will also go to 0 because of the obvious reasons, right? So that means if we apply n goes to infinity, this term will go to 0, this term will go to 0, and again any constant multiple of 0 is nothing but 0 only. So here we will have 4 into 0, which is nothing but 0. Right? So this will also goes to 0, this will also goes to 0, and this will also goes to 0. So that means if we apply n goes to infinity, the limit will be 1 by 6. Okay, so the answer is 1 by 6. So in such of type of questions, what you have to do, you have to pull out the largest power of n. Okay, so once you pull out the largest power of n, we can apply this limit 1 by n goes to 0 as n goes to infinity and figure out the answer. So in this type of questions, the answer could be over 3 cases. Either it could be 0. So it could be 0 when the numerator has the largest power. So that means in place of 5, if I have written n to the power 6, then we know that 1 by n goes to 0. So that's why the whole numerator will take the sequence to 0. Or we can get infinity if the power of denominator is greater than the power of numerator, and if the powers are same, we get a finite value, and that finite value is nothing but this coefficient upon the largest coefficient upon the that is 1 by 6 in this particular case. Okay, so I'll repeat once. So if you have a sequence of this type of thing, that en is nothing but some a1 n to the power we can take any number. So suppose I'll take r, then plus e2 n to the power r minus 1 plus and so on, plus I mean we just have a polynomial b1 n to the power p plus b2 n to the power p minus 1 plus and so on plus b. So if you have such type of sequence, then we have three cases. If r is equals to p, then limit of an is nothing but a1 upon b1. Right? Because if r is equals to p, you can take the largest power of n common from both numerator denominator, and we will get a1 upon b1 only, because all those terms will go to 0. Now the second thing is when r is strictly less than p, that is the power of numerator is strictly less than the power of denominator, then in this case we will get limit of an to be equal to 0. And the third thing is if r is strictly greater than p, that is the power of numerator is less now than the power of denominator. So then in this case what happens, we have a at least one factor repeat over the denominator. Yeah, sorry, we will have a one factor at least over the numerator, and this n will take whole sequence towards infinity. So in this case, we will have limit of an is nothing but infinity. Okay, so if both powers are same, then the limit will be finite. Then the value of limit is nothing but a1 by b1. That is the coefficient of largest power of n in both things, numerator, denominator. That will be our a1 by b1. The second thing, if the value of r is strictly less than the value of p, then the limit of sequence is nothing but 0. And if the value of r is strictly greater than value of p, then the limit of an is nothing but infinite. Okay, is that clear now? Okay. So now we can take one more example. So suppose I'll take this example. So suppose an is equals to 2025 of n to the power 2025 plus 2024 of n to the power 2024 plus and so on plus n plus 1. And the numerator, I have 2024 n to the power 2024 4 plus 2023 of n to the power 2023 plus and so on plus n plus 1. Okay. Now what do you guys think limit of n will be? So here the largest power is 2025. Here the largest power is 2024. Infinity. Correct. It will go to infinity. Right? Because it lies over the this particular case. R is strictly greater than P. Okay. So I mean you can answer this type question just by looking at the expression of a sequence. Okay. Now let's go to monotonic sequences and bounded sequences. Okay. So if what is an increasing sequence or decreasing sequence means? Okay. So first of all, increasing sequence. So increasing sequence means if an is less than an plus 1, less than or equal to an plus 1. So if you have a strict inequality, it will be strictly increasing. And if we have less than or equal to, it will be just said increasing. So if an is less than or equal to an plus 1 for all n belongs to natural number, then we say that the sequence is an increasing sequence. Right? So you can take an example of simple an is equals to n. So this sequence is increasing because n is less than n plus 1. That means an is less than an plus 1. Right? So it is an increasing sequence. 1, 2, 3, 4, 5, 6 and so on. Now second type of sequence is decreasing sequence. So decreasing sequence means if the value of an is greater than or equal to an plus 1 for all n belongs to natural. Right? So here we have a decreasing sequence. For example, you can take an is equals to 1 by n. Right? This will be a decreasing sequence because we know n plus 1 is greater than or equal to n. So 1 by n plus 1 will be less than or equal to 1 by n. So that means an plus 1 is less than or equal to an. Right? N plus 1 will be greater than or equal to n, which is obvious thing. If we move one step ahead, the value will be less. Right? 8 is less than or equal to 7 type of thing. And if we take the reciprocal, the inequality will change from greater than or equal to less than or equal to. Right? So 1 by n plus 1 is less than or equal to 1 by n. And this Yeah, so we can take another examples too about bounded sequences, about increasing and decreasing sequences. So let me give one example. So for example, if you have a sequence an is equals to 3n plus 1 upon 5n square plus 1. Okay, so now in this example, you can observe that this numerator will give us a smaller value than the denominator, because we have power here n square here, and here we just have 3n plus 1. So in this case, what happens, this numerator will go to infinity much more faster than the denominator. And so here we can easily observe that the value of an will be less than or equal to the value of an plus sorry, I have written the other way around. So here the value of an will be greater than or equal to the value of an plus 1, because in the denominator we are getting larger values. Right? So this sequence will now be a decreasing sequence. So you can judge the sequence's nature either by looking at the sequence or just finding out some relation. Yeah, you can compute the values of terms, but it may not work always. So here also, if you compute the term, you will get the pattern. So it's a good start. If you compute the value of ans, you will get a sense that it either decreases or increases. So yeah, you can do that too. So for example, if I consider the sequence, for example, if an is equals to 2 under the root of 3n. Okay. So now is this an increasing sequence or decreasing sequence? So what do you guys think? Is it an increasing sequence or decreasing sequence? an is equals to under the root of 3n. So yes, it is an increasing sequence, right? Because obviously we know that n is less than or equal to n plus 1. So 3 times n will also less than equal to 3 times of n plus 1, right? So that means under the root of 3n will also less than equal to under the root of 3 of n plus 1, which is nothing but an is less than equal to an plus 1. So this is now an increasing sequence. So you have to observe that the sequence is increasing sequence or decreasing sequence by the expression of the given sequence. Okay. Now we have another type of sequence which is known to be bounded sequence and unbounded sequence. Okay. So let's go to bounded sequence. So in bounded sequence, we have two types of bounds. One is upper bounded sequence and bounded below. Yeah, that means bounded above and bounded below sequence. So the first kind is bounded above sequence. So bounded above sequence means if you have a sequence an and if you are able to find a value capital M in such a way that an is less than equal to capital M for all n belongs to natural number. So that means if these are the terms of our sequence, we are able to find a boundary wall here, capital M, such that the all terms are lying over the left hand side of this particular M. Then these sequences are known to be bounded above sequence. Now what is bounded below sequences? Bounded below sequence. So bounded below sequence means you need to find a small m such a way that the value of sequence is nothing but the greater than equal to the small m for all n belongs to natural number. So that means all values of sequence are actually greater than equal to this small m. Then those sequences are known to be bounded below sequence. So over the graph, if you want to find, that means we need to find a boundary wall in such a way that all terms of sequence are lying over the right hand side. Those sequences are known to be bounded below sequence. See, I'll take the example. Now, what is a bounded sequence means? So, bounded sequence means it should be bounded below as well as bounded above. It is bounded below plus bounded above. Those are known to be bounded sequences. Okay. So, for example, I'll take the same example. So, suppose I'll take an is equals to 1 by n. Okay. So, here you observe that the value of a1 is 1, the value of a2 is 1 by 2, a3 is 1 by 3, and so on. Right? And here we know that limit of an is nothing but 0. So what is happening here? The value of an is actually greater than 0, but it is less than or equal to 1 also. Right? So this 1 will work as capital M and this 0 will work as small m. So now this sequence an is bounded below by 0. 0 is a 1 lower bound and bounded above by 1. So that means it is both bounded below as well as bounded above. So we can say that the sequence is nothing but a bounded sequence. Okay, I'll take one more example. So suppose we'll take the same example. So en is equals to some 3n plus 1 upon n square. Okay. So now what about this sequence? So I'll ask one by one. So is it bounded below? Is it bounded below? Is this sequence is bounded below? What do you guys think? Is this a bounded below sequence? So it's kind of obvious that you can judge. See, n belongs to the natural number, so that means n is positive, right? So if n is positive, 3n plus 1 will be a positive and n square will be positive. So that means ultimately 3n plus 1 and n square both are positive. So if both are positive, so we can say that an is greater than or equal to 0. So 0 mostly always work as a lower bound for some simple sequences which are not giving us the negative values. So this sequence is obviously bounded below, and you can take as small m, the value of small m to be is nothing but 0. This will work as a small m for us. Now what about bounded above? So here you can observe that the values of a1, so suppose I'll compute a1. So a1 is 3 plus 1 by 1 square, right? So which is 4. Now a2, so a2 is nothing but 3 into 2 plus 1 by 2 square. So which is nothing but 6 plus 1, 7 by 4, right? Now what is 7 by 4? So 7 by 4 is something 1 point, or sorry, yeah, so 1.7 or 8 type of thing, right? Which is less than the value of a1. So that means here a2 is less than a1. Now a3 if you compute, so a3 will be 10 by 8, right? So 10 by 8 will be again 1.2 or 3 something, right? Which is again less than a2. So here we are getting that a3 is less than a2 is less than a1. So that means this is a decreasing sequence. So you know that decreasing sequence, for decreasing sequence, a1 can work as a capital F, right? So here what we are getting 0 is less than or equal to an, which is strictly less than or equal to a1. So that means this is a bounded sequence. So it is bounded below by 0 and it is bounded below by a1. So this is nothing but a bounded sequence. Is that clear so far? Any doubt? Zero scale, that I don't know, but let's see. So those sequences are bounded sequence. Now what happens if we combine these two properties, that means increasing sequence and bounded above sequence, we'll get a convergent sequence. And if we combine the property of decreasing sequence plus bounded below sequence, we will again get a convergent sequence. So this theorem is known to be monotone convergence theorem. So what is monotone convergence theorem? So monotone convergence theorem says if we have these are two statements. So first statement says if our sequence En is increasing plus bounded above, then we will say limit n tending to infinity En exists. And when limit exists, we say it is a convergent sequence. And the second statement goes like if the sequence En is decreasing sequence plus bounded below, then also the limit n goes to infinity exists, and it's a convergent sequence. So that means we need to combine two property of sequence, either increasing plus bounded above or decreasing plus bounded below. If we have these two property, then we can say that a sequence is a convergent sequence. Okay. So one well-known example is this example. So suppose we have an is equals to under the root of 3n plus 1 and a0 is equals to 3. Okay. So if we have this sequence, then you can easily observe that it is an increasing sequence, right? Because a0 is equals to 3. So if you compute a1, a1 will be 3 into 3 plus 1, which is under the root of 10, right? So under the root of 10 will lie between, I mean, it's greater than 3 because under the root of 9 is 3. So it is greater than under the root of 9, which is equal to 3. So that means a1 is greater than a0. So here we have some sort of increasing sequence, but the sequence is not bounded above because it goes to infinity as n goes to infinity, right? So here we cannot actually apply. So it is bounded below plus increasing. But when we have increasing sequence, we need bounded above. So, but not bounded above. So here we actually cannot apply monotone convergence theorem. So we need to find one more example. So let's see this example. So suppose I have a1 is equals to 3 and an plus 1 is equals to under the root of 3 times of an plus 1. Okay, so suppose this is our example. So in this case, what we can see. So here also obviously it's an increasing sequence. So let's see it is increasing or not. But whenever we have a recursion type of sequence, then what you can do, you can, if you want to find out limit, so if you guess that okay the sequence may have the limit, then you can just apply, you can take L is equals to under the root of 3L square plus 1. Hello? Yeah. So whenever we have recursion type of sequence, then for finding the limit of this sequence, what you will do, will just substitute L in terms of an plus in place of an plus 1 and an. Then you can find out the limit. So that means if the limit exists, then limit n tending to infinity of an is equals to L. Then this will imply L is nothing but under the root of 3L plus 1. Which will say that L square is nothing but 3L plus 1. And this will imply L square minus 3L minus 1 is equals to 0. And now you can find out the limit. But I think this sequence will also possess a limit. Let me see one example over monotone convergence theorem. So currently, so I don't think I have any example now. So we have some common examples, those we already know, that 1 by n square. Those are monotone convergence theorem and all. Yes, Sanam, is there any doubt? Okay, fine. Let me think. If I get any example, I'll get back to you. But monotone convergence theorem means bounded increasing plus bounded above and decreasing plus bounded below. Okay, we need the combination of these two properties. Then we can apply MCT. Now let's go to the limit of our functions. So suppose we have a function f of x. Then we need to find out, or we need to talk about limit extending to x naught of f of x. What is this value? Is Just give me 5 minutes to reconnect. Hello. Hello. Yeah, sorry, it's taking a bit longer to connect to Wi-Fi. Just give me 5 more minutes. Either I'll try with the mobile network itself. It's possible to have a lag. So let me know if you guys face any lag on my screen or on my voice. Okay. So we was talking about limit of a function. So what we understand by limit of a function means. So here, as like the sequence, we need to answer the question that if x is going to x naught, where does the value of function goes? That means where does the f of x goes? Okay, so this is the question we need to answer. So for answering this question, formally we take the help of sequences. So what we will do? So we will try to approach. So we will try to approach the point x is equals to x naught from both the directions. So over the real line, if you find out this is your point, so the value of x naught, you can take anything. The value of x naught could be 1, 2, 3 or any real number. So what we need to do, we will approach this point x naught from the left hand side and from the right hand side. Okay, so this will be your left hand side, this will be your right hand side. And then related to these values, we'll try to figure out where the graph of function is going or where the function is going itself. Okay, those will be our left hand limit and right hand limit. And if by approaching both direction, we reach to a finite or we reach to a unique location, that location will be the limit of a function. So that means if the left hand limit is equal to the right hand limit, then that is the limit of function, limit extending to x naught of f of x. Right? So what we need to do, we need to approach the function from the left hand side of the point, from the right hand side of the point, and if we reach at a finite, if we reach at a unique location, that will be our limit of a function. Okay, so this left hand limit, so left hand limit at point x is equals to x naught, this is denoted by limit extending to x naught minus. Okay, so this is our limit, limit extending to x naught minus of f of x, and the right hand limit at point x naught, x is equals to x naught, this is denoted by limit extending to x naught plus of f of x. Okay, so if the right hand limit and the left hand limits goes to of same value, then this is known to be the limit of a function. Okay, and what is the continuity of a function means? So continuity means the limit of function should equal to the value of function. So that means we say the function f is continuous at point x is equals to x naught if the limit extending to x naught of f of x is equals to the value of function. So that means the limit of a function is same as the value of function, then we will say that the function is continuous. Okay, so this is the theoretical meaning. Now let's do some examples. So suppose I'll give you a function. So example is take f of x is equals to 3x plus 1 when x is greater than or equal to 1, and we will take x square when x is less than 1. Okay, so in this case we have to find out limit extending to 1 f of x. So what will be the value of this limit? Okay, so what we can do, we can think that what will be the left hand limit and right hand limit of the function. So let's talk about the left hand limit of f at x is equals to 1. So that means we need to talk about limit extending to 1 minus of f of x. Okay, so here f of x it's a piecewise function, so that means we have two expression related to a particular domain. So that means when x is greater than or equal to 1, we are following the expression 3x plus 1, and when x is strictly less than 1, we are following the expression x square. Okay, so that means if we approach the point x is equals to 1 from the right hand from the left hand side. Okay, so this is x is equals to 1, right, and I want to approach this point from the left hand side, right? So over the left hand side of the real number, we have all values which are less than 1, right? We have x is equals to 0, x is equals to minus 1, x is equals to minus 2. So that means for computing the left hand side limit, we need to consider the expression x square. Okay, so what we will say, we will say that this left hand limit is nothing but limit extending to 1 minus of x square. But we know that x square function behave very nicely when we reach the point x is equals to 1. So that means as x goes to 1, the value of x square will also go to 1. Right? So this limit is nothing but 1. Is that clear? How we get the left hand limit is equals to 1? Any doubt? Am I audible? Okay. I hope I will be audible. Yeah, I'll take another example too. But what will be the right hand limit in this case? So right hand limit of function f at x is equals to 1. So that means we need to compute limit extending to 1 plus of f of x. So in this case, we need to consider the upper expression, limit extending to 1 plus, because we are approaching the point 1 from the right hand side. So that means we are taking some bigger values of m, bigger values of x, bigger values of x. So we have to consider the expression 3x plus 1. So as x goes to 1 plus means we have to consider 3x plus 1. But it's again a linear function. So as x goes to 1, 3x plus 1 will go to 3 into 1 plus 1, which is nothing but 4. So here what is happening? We are having left hand limit is not equals to right hand limit. Okay, which is 1 not equals to 3. So that means this limit does not exist. Limit extending to 1 f of x does not exist. Okay, so I'll take one more example. I'll take graphical example. So suppose we have a function given by this particular graph. Again, the convention is if we have a solid point, then the value of function is this at that point. Okay. So suppose this is -4. This is x is equals to -5. Okay. And then we have something like this. Okay. So suppose we have these, this is our function. It is again piecewise manner. So this is x is equals to 2. Okay. So now what we need to consider, we need to find out several limits. So the first thing is find out this limit extending to -5 of minus of f of x. Okay. So what will be your answer now? Limit extending to -5 minus of f of x. That means the left hand limit of function when x goes to -5. Anyone can answer this one? The left hand limit of f when x goes to -5. Yeah, f is not continuous at -5 and x is equals to 2, but we can find the left hand and right hand limit, right? What will be the left hand limit for x goes to -5 minus? That means the left hand limit of f at -5. Okay, so here, see, when we approach the point x is equals to -5 from the left hand side, the graph of function approaching to the value -4. So that means the value will be -4. Left hand limit of the function at -5 is -4. If you compute the right hand limit of x going to -5 plus f of x, so here we are approaching the point x is equals to -5 from the right hand side. So the graph of function is actually approaching to the point x is equals to -5. So that means here the right hand limit is -5. So left hand limit not equals to right hand limit. That means limit does not exist here, and uh, so since the limit does not exist, obviously this is not a continuous function. So expression of this function I actually don't know. I just draw something, but without expression, just by looking at the graph also we can compute. The expression will be some straight line here, some straight line here, then some parabola here, and then again some straight line here. So you will have four pieces of this function. Okay. Now, can you guys tell, is it continuous at x is equals to 0? Is this function continuous at x is equals to 0? You can answer this yes or no. Why is not continuous at x is equals to 0? See, this is our x is equals to 0. And here we just have same thing. It will be continuous, right? It is approaching to -5 from from left hand side. It is also approaching to -5 from the right hand side, and the value of function is also -5. So that means both things are same. Left hand limit. So here left hand limit at x is equals to 0. This is -5, right? Because if we approach x is equals to 0 from left hand side, we need to follow this line segment. and this line segment is approaching to the value x is equals to minus 5. So left hand limit is minus 5. Similarly, right hand limit is also minus 5 because we need to follow the parabola, but the parabola is also approaching the point minus 5. Right? Yeah. So if you can solve such type of problems, you're good to go for limit and continuity. Yeah, it is discontinuous. See, it is possible to have continuity by parabola and line segment too. For example, if you consider the piecewise function f of x is equals to x square when x is greater than equal to 2 and 3x plus 1, then x is less than 2. Okay, so here what will happen? Left hand limit will be 3 into 2 plus 1. Okay, so maybe here we don't have continuity, but we can get continuity. So maybe not here. I need to check the expression. So it is possible to have such type of function. So for example, it's going like a straight line, and then from here it is continuously changing like a parabola. Right? So such type of graph. So it will be continuous at x is equals to 0. Okay. So the answer is yes. Because left hand limit is minus 5, right hand limit is minus 5, and f of 0 is also minus 5. And which is the things we need for continuity. Okay. So that's all from my side. Now, if you guys have any doubts or questions or any topic which is not clear or you want me to repeat, we can do that. So just unmute yourself and ask the doubts, or you can ask for revising any other concept too. I'll share this document over the calendar. You can download it from there. Okay. Anything, any doubt? Yeah, what the quiz one paper. So let me see. There should be revision classes for the C and ESTC. So I'll check with them. So let me share my screen. Let me download the question paper. Okay, so this is the qualifier question paper. This term. So here we have first question. So first question is just based on straight lines as we have discussed. So two straight lines are given to us, and then we need to find the point of intersection, right? So if this is the point of intersection, then we know that if this point lies over both lines, then P comma Q satisfy both equations. So just substitute x is equals to P, y is equals to Q, and you will get your answer there. Okay. So the first question, I think it's easy. The second one, just let me know if you want the detailed explanation of any question. Okay. So the second one is consider the system of linear equation. Two equation is given to us, and then they ask about no solution, infinitely many solution, or unique solution. Okay. So the process is just find out the matrix representation of this sequence. This system, and then reduce it into required form and apply the three cases. We have discussed the three cases when r is strictly less than n, strictly less than n, r is equals to n. Okay, you can answer this uniqueness and those type of questions. Okay. So third question actually need the definition of sequence. Okay. So we know that any function from set of natural number to any other domain represents a sequence. So that's why here option number A is correct, but option number B is not correct because here the domain is given to be set of integers. Right? So option number A is correct, B is not correct. And C says if AN is convergent sequence, then 10 to the power 10 of AN is also a convergent sequence. So this is also correct because we know that if AN goes to L, then any constant multiple of that sequence will also goes to constant multiple of L. Okay. So we just use the same thing to say that this is also a well-known thing. Okay. But D is not correct. So if 10 to the power 10 AN is a convergent sequence, then AN need not, okay, B is also correct because is need not to be is given to us, right? Because again, what you know that if 10 to the power 10 AN is convergent, so let me share my screen. Okay. So here, see, if AN converges, then we can say that any constant multiple of AN also converge. This much we know, right? Because constant multiplication does not affect the convergence or divergence of any sequence, right? So here it's given that AN converges. So we can say that okay, AN converges means 10 to the power 10 AN also converges. And in this is given in the C option. In the D option, it's given that 10 to the power 10 AN converge. So what will be AN then? So AN is nothing but 10 to the power 10 multiplied by 1 by 10 to the power 10 multiplied by the convergent sequence, right? So that is 1 by 1 by 10 to the power 10 multiplied by 10 to the power 10 of AN. It both cancel out. And this converges. So any constant multiple will also converge. So that means both implies. So if EN converges, then 10 to the power 10 EN also converges. And if 10 to the power 10 EN converges, then EN also converges. But in the option, it's given that need not to be. Okay. So because of that, this option is incorrect. Because of this thing, need not to be. Okay. Now let's go to the fourth question. So here AN is equal to 3n minus 5 upon 4n plus 2. Okay, so AN is equal to 3n minus 5 upon 4n plus 2. So here also you can observe that as n goes to infinity, this numerator will give us a smaller values. And this denominator will give us a bigger values. Right? So it should be a decreasing sequence. Yeah, the answer should be B, that it is a decreasing sequence. Because if we take some smaller values, the numerator will become bigger. So that's why this is a decreasing sequence. Okay. So here the answer is wrong. So this should be B. And we can find out the limit of a sequence too. So here the limit finding is easy one. So limit of n is nothing but n of 3 minus 5 by n into n of 4 plus 2 by n. So as n goes to infinity, this 5 by n goes to 0, 2 by n goes to 0. So we get 3 by 4. So this is the limit of e. So then what will be the limit of a? So 8an square minus 2an. So the limit will be 8 into 3 by 4 the whole square minus 2 into 3 by 4. Okay, so that is 8 into 9 by 16 minus 2 into 3 by 4. Okay, so we can compute it. So this will be 2, so it's 9 by 2 minus 3 by 2. So this will be 9 minus 3 by 2, which is 6 by 2. So the answer will be 3. Okay, so we can find out the limit if we know the limit of E. Now we have a similar type of question. See, so consider the graph of the following function with the bullet point represent the point attained by the function and the circle represent the point not attained by the function. So here what are the options we need to check? We have to find out continuity at a point. So it's kind of obvious that function is discontinuous as -4 and -3. So only at -4 and -3 function is not continuous. So f is not continuous at x is equals to -4. F is not continuous at x is equals to -3. So that's why B and C options are correct. Now we need to find out left hand limit of -4. Okay. So here you observe that as we approach -4, the value of function is approaching 1. Okay. So value function is approaching 1. See, this graph is ending at 1. So we need to find that point where the graph is ending. Right? So that's why here left hand limit will be equal to 1. And similarly, the right hand limit at 3, at -3. So at -3 also, the graph is approaching to the value 1. Okay. So that's why the right hand limit is 1. So the both options answers is 1. Okay, is that clear? Any doubt so far? Fine. Now let's go to the second section. So the first one is just a quadratic function. You can answer that question too. The second one is system of linear equation, we know. So this actually reduces to two variable, two equation, and then you need to solve it. The similar question we have in graded assignment, right? So you can check that one too. Now here, see, these sequences limiters are very easy to compute. So in the first one, we know that if you pull out n to the power 4 from both numerator and denominator, the answer will be 4 by 2, which is 2, right? So that means the error made by algorithm 1 is 2. The error made by algorithm represented by the sequence Bn is 1 by 5, which is 0.2. And the last one is 0. Okay, so you can answer this one too. And same thing is here. Now compute the limit of function. So both are same type of example we have done. This example already we have done. Okay. And this one too. So it's better to go by so I'll say just go by PYQs, AQs, and GS plus this qualifier exam paper. Okay, that these four things will be much more enough for preparation of Rerun qualifier. Okay, so if you guys done this much things, then it's very easy to crack the paper. Is that okay? Any other doubts? Okay, so I'll talk to them that what they are going to take revision session or not. But the reason I actually don't know, so I'll let you guys know. Any other thing you want to? Actually, I don't know. I'll talk to sir and they will send you the announcement because your question, I mean, exam is on 17th, right? 16th. Okay.